Okay, this should be a simple, short, one-shot video about safe cracking gameplay using an old school tumbler. So let's go ahead and drag and drop our 3 images into the scene. Let's take that handle and move it over. Let's take the white background, move it up. And since it's too wide, let's shrink it. We'll go to 0.4. And for the tumbler, let's move it to ordering layer 1, that way it's on top of that background. It's important to point out that this image does not actually functionally do anything. It's simply to indicate to the player what the current number is. We're going to track the number using a different means. Second of all, it's also important to note when you're drawing these images, there's something you have to be aware of. The numbers need to be equidistant. Now that might seem obvious, but I mean it really has to be as exact as possible. Now to know how to make them equidistant, when you rotate an object completely around, it's 360 degrees. So if you have, in this case, 8 numbers, what you do is you take 360 divided by 8, that comes out to 45. So when you're drawing this image, you put the numbers 45 degrees apart. So the image has to be centered, it has to be as perfectly circular as possible, and the numbers need to be equidistant. The second image is this image. In this case, you want the circular part to be centered. So if you look down here in the assets, you can see that only the circular part is centered, everything else goes off to the side. And the reason for that is we want the circular part to be the pivot. So now let's look at scripting. Right click in the asset area, choose create, choose C# script and call it Safecracker. We're going to click on Tumbler, go drag and drop Safecracker onto it, and then we're going to click into it. Now I've already written the script separately in a text file, so I'm just going to copy and paste it a little bit at a time and explain it. So first we're going to create what's known as a list. A list is a special type of variable. However, the list won't work until you make a change up here. So using system collections generic. So system.collections.generic. Now let's go ahead and put in our 2 list commands. So public static, so static, that means this variable is going to be available anywhere in the application to any object via any script. List, okay, it's a list type of variable. Now what are the data types within that list going to be? Are they going to be ints, are they going to be strings, or are they going to be floats? That needs to be surrounded by a less than and greater than sign functioning like brackets. And then the name of the list. The name of the list is selected nums. So that is going to track the numbers that you are selecting on the tumbler. Equals new list float. So this needs to mirror this. Okay. Open close parentheses, and then in this case open close brackets. Now what happens is the variables are stored, or shall I say the values are stored within the brackets. The values are stored within the brackets. Okay. This one is going to start with no values because this is going to track the numbers you're choosing on the tumbler. So let's look at the next script. Same thing, public static list float. This case it's current combo. In other words, you're going to be able to change the combination number to whatever you want. Now, if you don't want to do this, you can just not do this, and later on I'll show you where you'd put in constants instead, but more than likely you're going to want your combination to change, particularly if safe cracking is a key part of your gameplay. So current combo equals new list float, so same as this. Now in this case there are some values, 8, 3, and 6. Those are just numbers I randomly grabbed. So this is position 0, this is position 1, this is position 2. It's very important to remember that that it starts with the 0 position. Now, if for some reason that's giving you trouble and you really want to start with the first position, you can always just put a dummy value here and adjust for that this is position 1 and this is position 2. But yeah, this is the 0 position. There's no way to change it. So position 0, position 1, position 2, so on and so forth. There's only 3 numbers because in this case we're going to use a 3-digit combination. Let's look at some more of our variables. So this is probably the most complicated, is getting the list just right. Because like I said, you got to make sure you do this or else list won't work, and you got to get this syntax exactly correct. So let's look at the next two. Public key code, clock W and counter clock W. Again, what you name it doesn't really matter. This is just for your own personal knowledge as the designer that, okay, I'm going to use this key to move clockwise and this key to move counterclockwise. So public key code, so that means we're going to have to assign keys to this. Public static float, so that means this is going to be a variable available anywhere in the application. So public static float, so it's going to be a float, not a string or an int. Current num equals 1. This is what's tracking the number that is currently selected on the tumbler. So this is just like everything else, it's very important, but this is the number that you are pointing at on the tumbler, and so this is going to be changed as you rotate the tumbler. Public float selected number position. This is going to be used to determine which number we're looking at, because as we said, this is the 0 position, this is the 1 position, this is the 2 position, so we're going to use a variable to track which position we're looking at. Public string current direction none. So at the start you have moved in no directions. Now the reason why this is necessary is because typically the way a combination lock is you turn it in a certain direction, you settle on a number, and then you turn it in the opposite direction. So that number that you stopped at is the number that gets selected. So the easiest way that I can think of to do that is just to, when you change direction, whatever the number was that you were sitting on, that is the next number in your combination. And so to do that, you just look to see when you've changed direction. So we'll get to that in a minute. And actually, we'll get to that right now. So as I just said, the bulk of the activity is just changing direction. You're turning left or you're turning right. You're turning counterclockwise, you're turning clockwise. So if input.getKeyDown happens once. It's the single frame in which you've pressed the key down. If you use just getKey, then it's a rapid fire, and you don't want that. You want one press to per number change. So if input getKeyDown clock W, so that's this key. So if you're pressing this key, transform.rotate 0045. That says rotate the image that this script is attached to by 45 degrees on the z-axis. Well, it's attached to the tumbler, so it's going to rotate it on the z-axis. Just going to rotate it clockwise or counterclockwise. Okay, so whenever you press the clockwise key, we always want it to transform. We want it to rotate. Okay? But what we don't necessarily want it to do is the next part. So like we said, current direction. What direction are you moving in? It starts off as none. If current direction is equal to counterclockwise, so you're moving clockwise. If you were previously moving counterclockwise, then that's where you need to select the number. So like I said, you're moving, say, clockwise, you stop, you change direction. Well, whatever number you were on when you changed direction, that's the number you've selected. So that's what this is doing. This is saying, did you just change direction? If you did, okay, then selected nums dot add current number. So selected nums, as we said, is the combination, and you're adding this into the next open spot. Well, there are no numbers, so it puts it into the 0 position. So, and as we said, selected number position starts as 0. So now bump that up to 1 because the next time you add a number you want it to be on the 1 position. So that occurs with this being true. That if the current direction is counterclockwise and then you move clockwise, then do that. We then want these two things to happen, but we want them to happen after we've checked. Now that we're moving clockwise, we need current direction to be equal to clockwise, and we need the current num to be increased by 1. So in other words, we said current num is whatever number the dial is set on. So this is what's tracking the actual combination number that you're pointing at. Now, the second part is really just rinse and repeat. What you're doing is now you're looking for the counterclockwise. So make sure it's outside of this, but inside of update. If input.get key down is counterclockwise, so if this key has been pressed, transform.rotate 0, 0, negative 45, so now you're rotating negative 45. And again, I said that that number is derived by however many numbers you have, how many positions you have, divided into 360. And now we're checking for just the opposite. If current direction is clockwise, while you're moving counterclockwise, selected numbers.add current num. So again, you're increasing, you're adding a new value here in the next position. Selected position number is increased by 1. So in other words, you're going to check how far you're out. Current direction is counterclockwise now because we said you're moving counterclockwise, and the current number you're looking at is decreased by 1. So if you're moving counterclockwise, you're decreasing the number by 1. So like I said, this and this, really the same thing. It's just a matter of are you moving left or are you moving right. All the functionality is line by line the same. It's just whether or not you're rotating 45 or negative 45. Are you setting it to counterclockwise or clockwise? Now, the one thing that this does not check for, however, is it does not check if you've gone from 8 to 1 or 1 to 8. So we need to put that into both of these routines. So when current number is increased, because we said that is what number is being pointed at, so if current num is greater than 8, then current num should be set to 1. I could have done this the first pass through, but I thought this was kind of busy to begin with, so I figured I'd add it after we reviewed the basics. And again, positioning means everything as far as when I'm checking. I want to make sure this has been modified first before I make the change. So, in this case, if it's less than 1, then current number gets set to 8. So, that should pretty much do it for the safe cracking. I suppose we could put in a debug to see if it's working, but I'd already tested it, so it should. Now we need to add a second script. This second script is going to control the handle, because once you've entered the combination, you then turn the handle to check to see if it's worked. So right click, choose create, choose C#, and we'll call it handle control. We'll click on the handle, click on add component, physics 2D, polygon collider is trigger, has to be a trigger to be clicked on. Take handle control and drag and drop it onto the handle, and then go ahead and open that up. Let's see if this will copy and paste for me. It was giving me trouble a few seconds ago. Okay. So outside of start, outside of update, you add void mouse down, on mouse down. This is pre-defined, so you need to make sure it's capital O, capital M, capital D, or it will not work. So on mouse down, has the left mouse button been clicked on the object this script is attached to? This script is attached to the handle. Now, ignore this for the moment. We're just going to look at part of this. This is where we're checking to see if the number you have selected, or combination of numbers, matches the combination for the safe. So at the very beginning, we talked about how we had the selected number list, which is blank, which is built every time you turn the combination in a different direction. You're turning right, 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 then you turn left, records that number. Turn left, 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 and then you turn right, or whatever. Bottom line is when you change direction, the number that you were on when you change direction is the entered number. You're checking that number that's been built versus the pre-existing number. So you're checking selected nums to current combo, and that's exactly what you see here. Safecracker, and since it's a static variable, we have to say where it's defined, so it's defined in Safecracker. So Safecracker.selected nums, the 0 position, so open bracket or square bracket, close square bracket with a 0 in between. We're checking the 0 position to the 0 position of Safecracker.current combo. So we're checking the 0 position here to the 0 position here. There's just nothing in here, so there's nothing to point at. But like I said, as you've been turning the lock, you've been building this. So let's compare the 0 positions of the two numbers. Well, it's a 3-digit, so you don't want to compare just the first digit. So and it's the double ampersand, if the, again, selected num, current combo, now it's the first position. So if the first position of those two match, so the 0 position has to match, the first position has to match. Now the third number, we have to deal a little bit differently. Because what we want for the third number is we don't want the selected num, because this gets set after we check to see if we've changed direction. Or should I say, when you change direction, it changes. Well, for the last number, you're not actually changing direction. So for the last number, you want whatever number it's currently sitting on, because you're going to turn, say, right, and then left, and then right, okay? Well, you don't want to turn it left again before you select, before you open the, you turn the handle. You want whatever number it's sitting on. So you're checking the selected nums for the 0 position, for the 1 position, but then for the third digit, you're checking current num. So current num, like I said, that gets increased here. So for that final number, you don't care, or shall I say, you don't want to move the, you don't want to change direction. You want whatever number it's sitting on in the current direction. So Safecracker.current num is equal to the second position, or really the third number, but it's in the number 2 position. So it's kind of a lot to look at, but like I said, principle, it's really, you're just checking you're checking the 3 numbers of current combo, so the 0, 1, and 2 position, to the 0 and 1 position of Safecracker, and the current num for the third digit. And it's kind of a lot to look at, so if you want, I'll expand this. I zoomed out so it'd be easier to see, but now it makes it harder to get the whole thing on the screen at the same time. But let's see if I can. I'll tell you what, I'll zoom in just a little bit. Let's see if we can get the whole thing at once. There. That we can actually bring down to the next row. So Safecracker.selected nums bracket 0 bracket equals Safecracker.current combo bracket 0 bracket, and then parenthesis, and then the whole thing has to be within parentheses. Because that's so complicated, I'll probably drop this script in the I'll create a folder on Dropbox and put the script in it, because that is a lot to type out. So if that is true, when you've clicked on, so you've clicked with the mouse, it checks to see if those numbers are true, are all matched, then it says okay, correct. In this case, we will do the debug. Else, selected nums.clear. So the name of the list .clear with an open and close parentheses afterwards. That's how you wipe out all the values. That's how you go back to this blank, because presumably the person's going to get it wrong the first time. If they do, then you need to wipe out those numbers and start from scratch. And that's how you do it. Selected nums.clear, open and close parentheses. Safecracker you have to use because, again, the variable is stored in Safecracker. Okay, so let's run this, and this should work. So currently I have the combination set at 836. Let's go ahead and run it. And actually, did I assign the arrows yet? Yes, I did. Okay. So So 8, now we're going to go the opposite direction. 3, and now the opposite direction. Now I'm going to click on the handle. And down here it says correct. Now, just to demonstrate that that it's not a false positive, we'll do 4, 6, 7, click on it, and it doesn't give correct. In fact, it says out of range because now there's too many digits, so it's working as intended. So, let's now do one more thing. We want to rotate, so instead of saying correct, we want the handle to rotate. So transform dot rotate and again this is going to rotate on the z-axis. We want it to rotate by either 90 or negative 90. Let's see which one's right. So again it's 836. So 8, 3, 6, and it rotated. So there you go. Now you could do like an animation that has like the safe open up, and you have whatever it is that's in the safe. So that should do it. If you have any questions, just let me know. But that should do it for this demo.